Hi, everybody. So welcome back to the Secure Ideas Professional Evil Webcasts. Today we are going to be talking about navigating cloud security with two of our consultants. And let's go to the next page. There we go. I'm just going to, we have a lot of content today, so I'm just going to briefly introduce them, and then we will jump it straight into the presentation. So we have two of our consultants here. These guys have a lot in common in that they are both automation enthusiasts in their own way. It's really exciting to have them present on a topic that's cloud oriented because of that tie-in with automation and DevOps and all that kind of good stuff. So we have Doug, and Doug is works a lot with cloud stuff, but from a hobby perspective, one of the most outstanding parts of what he does is he builds with robots. You do battle bots and stuff like that, right? So it's
Yep.
And you've done droids for various different other things, and so it's just been, you've been doing this for years, basically playing around with building things that move. So which is really cool. And Alex, your focus has been a lot on standing up large amounts of infrastructure. You've done a lot of things on automating like Kali builds and stuff like that. So been seeing a lot of Ansible and Terraform and that sort of thing out of you for quite some time as well. So again, lots of automation, lots of cloud oriented stuff, and a bunch of open source contributions as well, which is good to see. So with that said, I am going to just pass it straight over to you guys, and I'll mute myself unless there are questions. If anybody has questions, go ahead and ask them, and we'll try to find a good time to slide those into the discussion if we can.
So we're going to start with our agenda here, which is we're going to start with an introduction of what the cloud is and what security is around it. We have a couple examples of breaches that have happened based on cloud security. We're going to go over the key controls, and along with that, the examples of our major players in the cloud world, which is AWS, Google, and Azure. And then we'll have a wrap up and Q&A.
Awesome. So what is this cloud thing anyways? It's pretty well known by now, but we did want to kind of give like a higher level overview. This is kind of a quote from NIST. And so essentially it requires that the services need to be on demand and self-service so that there's not any type of human interaction, which would be like a colo or a co-location. That would be kind of the opposite, where it wouldn't be self-service. It needs to have broad network access so that way you can access those services provided by those infrastructure providers over the internet. Next needs to be resource pooling, so that way you can actually have a resource that is ready for you to actually spin up for multiple clients. And so it's kind of got that multi-tenancy aspect of it, but that way it's also not bottlenecking your actual clients that are using those resources as well. It needs to have rapid elasticity, so that means that you can kind of, paired with resource pooling, you can spin up things very fast, and it allows you to quickly expand and contract based on what you need from the actual cloud itself. And then measured services is kind of more of like the usage aspect, and so it needs to be able to observe your utilization and be able to, from the cloud owner's perspective, be able to charge you for that utilization. So that's kind of a high level overview. So long story short, what does all that mean? Effectively, it can reduce your costs and it can improve your security. Can is italicized for a reason, because with this versatility can also come with complexity, which we'll cover more throughout this presentation. But long story short, it allows your business to be enabled and enhanced compared to you having to buy everything up front and wait for things to come in, and it allows you to be a lot more fast-paced. Awesome.
So some examples of cloud security breaches we're going to go through today. We're going to go through 3 of them. The first one I talk about is the Toyota motor breach. This was discovered in May. It affected 26,000 customers' data. They were subscribers to their product, which is Toyota Connect, which what some of the data that was leaked was vehicle data and customer data. Toyota is very vague in what exactly was happening in the cloud that happened. They said it was just misconfigured cloud environment. It was bad information, insufficient dissemination and enforcement of data handling rules, which has caused this breach. What's interesting is the breach was active from 2015 to this year, and they finally plugged all those holes. But some of the data that was leaked was in-car data, geographic data, map data, and there was also user information. Our second one happened back in 2017, which was the Uber data breach, which was someone had got unauthorized access to Uber's cloud data infrastructure because there was credentials stored in a GitHub repository, which became public. This is a situation where there was a lot of information that was dumped, including driver's license numbers and the people who were attached to those, which were their drivers. And Uber initially tried to cover this breach up by paying the hackers $100,000 to delete the stolen data, but eventually it was made public, and this led to a lot of reputational damage for Uber. This incident highlights some of the importance of coding practices and proper authorization controls, and robust incident response protocols in cloud environments. And you need to have timely disclosure of security incidents. If they probably hadn't waited so long to disclose it, they would have probably not had the reputational harm that they ended up with. The next one is actually AWS. There was a leak of a Prime data video leak. Now, there were 2.5 million entries of data, but they were anonymized. But this information was what movies were being streamed, what kind of devices they were streamed on, network quality, and details about the subscription, such as if it was a Prime customer or not. Interesting, the database was called Sauron. I just think that's interesting because, yeah. It was actually an internal Amazon server that was accessible via the internet. And the database was not password protected, and it could be accessed with anyone with a web browser just knowing its IP address. This lab highlights a common problem that underpins many data exposures. Misconfigured internet-facing servers are left online without a password for anyone to access. The irony of that AWS and an Amazon service is what got popped on this, shows that this security is hard and misconfigurations can happen very easily. And as we talk about that, we're going to move on to some of the specific risks. Overly permissive, which is not having a password on your database. Lack of experience, which there's so many choices within a configuration for your cloud security that you can miss something small, and just not through lack of experience in cloud, you open something up that you don't mean to. And also business continuity. Like, what happens if there's an AWS outage? Like, AWS goes down, suddenly people can't stream their Netflix because Netflix is using AWS. Well, that's bad for Netflix. It's also bad for the viewers. And Alex is going to give you some more details on these.
Yeah, so kind of like this picture of tubes, that's how your AWS account can look. So being overly permissive, one of the bigger concerns for that is an insider threat. Before, with data centers and virtual appliances, it was a lot easier, or it could be to where it's more gated. And so it's easier for the administrators to have almost like a perimeter around those devices and those physical appliances. But versus now, the cloud, everything is just an API call away, or it's just an HTTP endpoint away. Like Doug had given during one of the specifics of the examples, someone just could navigate to a database and be able to access the information. So that's an example of everything being online means that you need to always have consistent security, and you need to be ready for that attack, because it's not a matter of if, it's a matter of when. And leading on to that, breaches, like I said, since it's got that always on perspective, we saw 3 examples of breaches today, and it just means that you always have to be thinking about security from the beginning of a deployment or a beginning of a service deployment. So that way you don't end up being a company that gets listed under the breaches. So next control is lack of experience, misconfigurations, and best practices. There are a lot of best practices out there, and it's hard to kind of try and find what is the best practice for you and your company, and kind of having that translation or that lingua franca of what is applicable to you versus someone else. And kind of just to give you an idea, this is what's called the CNCF landscape, the Cloud Native Computing Foundation. And this is a interactive website. So this screenshot doesn't do it justice. It's actually really useful for being able to do discovery of different tools. But you can interact with this website and explore the different types of categories for being able to implement into your cloud, the different tools that they've categorized and their different maturity levels. So the link is the l.cncf.io, and it brings you to this landscape. And there are about 20 categories, and each of those icons are different tools in the actual categories. So imagine wrapping your head around best practices for, at minimum, 20 categories of tools. It can be very overwhelming, and it can be expensive as well, because you have to learn and be able to pay for certain things, pay for certain tools. It can also be expensive because if you take a more older mentality perspective on it, and you do what's called a lift and shift, and essentially you just redeploy the same application you have on premises into your cloud, it will cause you to have more of a cost compared to developing more cloud native. Which developing more cloud native means leveraging services that were meant for the cloud into your actual cloud accounts, compared to just deploying servers and lifting and shifting your app to the cloud. You also have to think about exposed credentials. Whenever you do deploy like a lift and shift perspective of this EC2 instance, for example, for AWS, gets spun up, there are credentials that are actually associated to that service, that server, which is not something that you would inherently think of whenever you're doing a lift and shift. So you have to be cognizant of the potential credentials that could be associated either to your service or to your server. And then lastly, compliance, because there is so much technology that you have to be cognizant of, you have to make sure that you are adhering to the data locality laws for in your region, and then also for things like making sure you have encryption at rest for S3 or the server, simple cloud, simple storage solution, object storage for AWS. So that way you're making sure that you encrypt all of your information and it's not just in plain text. And then lastly is business continuity. Hopefully this is not ever you on the right-hand side, where you're praying that your DR plan goes according to plan. But what happens whenever your cloud goes dark and you aren't able to communicate with any of your services or servers? What is your plan? What happens if a server becomes quote unquote corrupt? We had that happen to one of our servers where we deployed it just like all the other ones, and eventually it became what was called corrupt, and it could no longer function. So making sure you have adequate backups, and replicating those backups to other areas, so that way in case your region goes offline, it's really important. And then what happens, like I kind of said, when your cloud goes dark, do you have a high availability plan, which is either hybrid or multi-cloud? So you have to kind of think about these security concepts and these concepts in general whenever you deal with the cloud. We already kind of talked about data integrity with encryption and at rest and stuff like that. So awesome. Doug, I think this is you.
So now we're going to go over some of the different key controls that we can use for just secure our cloud. And as we go through those, we're going to then review some of the different nomenclature that Amazon and Google and Azure use to differentiate themselves from each other.
Awesome. So the overview on the left-hand side is to show you where the actual cloud providers are going to be lined up whenever we do go into the cloud-specific implementation, and they're going to have their individual icons, which would be the AWS logo, the Azure logo, and the GCP logo. They're going to be located in the top right-hand corner. And then this is the actual topic area that we're going to cover, is these bubbles in the center. So we're going to go over least privileges, account segmentation, logging and monitoring, native security tools, and best practices validation. It's going to be a lot of information, so bear with me. We're going to try and get it through it as easily and quickly as possible. Let us know if you have any questions. So, and just remember, we're going to go over cloud-specific implementation information right after the different concepts. All right, so here we go. So the more cloud agnostic perspective of this for least privileges is identity and access management. That's how you manage your permissions and privileges in the individual clouds. For that, there are two different types of privilege, or two different kinds of interactions. There's human interactions and computer interactions. So identity and access management, or IAM, you can configure and modify the authorization and authentication for humans. So that can be either through the individual cloud vendor's web UI. That way you can log into that cloud vendor. Alternatively, you can also configure SSO. So that way you can have a centralized authentication location, and then that actually authenticates the individual into your cloud account. This allows you to kind of have the best of both worlds, where you can have that central authentication, but also be able to interact and communicate with all the other various clouds. Authorization allows you permissions to those individual cloud resources. So for example, if I'm accessing a server, or if I wanted to try and access a server on Amazon, then I would need permissions for the EC2 instance. And so I need to be granted those through authorization. And then the break glass account below that, you can almost think of that as like a Windows prompt of like, enter in your admin password here. But you can essentially elevate privileges on demand whenever necessary. So that way, if you do have some type of incident or issue, you can promote your access to a more privileged role. Ideally, you want to make sure that those are like heavily tracked, so that way someone isn't abusing them. But it's really important and allows you to kind of grant people that admin access just in time. So that's the human interaction perspective. And then from the computer interaction perspective, it's more cloud service account. And that's essentially, think of like a Windows service or a Linux service on the operating system. It's more of like in the background, not something people typically interact with. So that way it's more integrated into the actual cloud, or in my examples before, into the operating system. And that allows you to keep things running in the background and do periodic checks for things. You can also think of it as like continuous integration and continuous deployment tools. If you're actually trying to deploy something into your cloud, you don't want to have someone manually deploying it if you can. You want to be able to have a service account that deploys things for you. So that way it's more automated. Resource permissions, that covers individual resources in the clouds. So for example, a S3 bucket. And if you haven't noticed now, we are primarily an AWS shop. So a lot of my examples are AWS because that's what we're most familiar with. So excuse the non-examples for other cloud vendors. But it kind of gives us a general understanding. So resource permissions for an S3 bucket. That S3 bucket can have permissions saying, oh, I am allowed to access certain things inside of your cloud account, or other services are allowed to access me. So it's not only just, hey, can this person access my resource, this resource? It says, hey, can other resources access this resource? And then next would be network security. And so these are essentially like, think of a firewall, but being able to do firewall for not just the operating system level, but at a network level in general. I think the best analogy is probably just that firewall perspective. But it's not at the actual OS level, it's higher than that.
Alex, there was a question in the chat. I don't know if you saw it.
I did not. Do you mind reading it?
Yeah, sure. So for those that are multi-cloud, how do you also handle I want to do it the cloud way, but then end up having three different ways to do that because you have three different clouds? So are there reasons or benefits from doing something with a cloud specific or native tool versus a cloud agnostic tool that can overlap different cloud environments?
Yeah, that's actually a really excellent question. So it, unfortunately, I hate giving this answer, but it depends on what's best for your use case. So for a smaller shop, so like for us, we have like 20 something people. Doing it a cloud way is a bit easier, and then we can just add to the other cloud as necessary. Using tools like Terraform to do infrastructure as code allows you to kind of apply those permissions in a contiguous way across cloud providers. So infrastructure as code is essentially it's almost like you're coding, but then with that code, it then gets executed, and its execution then deploys the state of your cloud. So being able to actually deploy a server across all three cloud providers can be done in a more agnostic way with Terraform by creating modules. So that way you can say, hey, I want a server and I want it on this cloud. And so that way, or if they don't care about the cloud at all, they can just deploy it, and then the module will choose where it goes on the back end. So you can have that more agnostic way of creating things, but still have the individual cloud implementation on the back end. Alternatively, there are other tools like Kubernetes, which I don't advocate for very often. I love the versatility and power of Kubernetes, but it is very complicated. But it is a extremely good way of being able to implement something that is cloud agnostic, because you do that definition and you don't even have to worry about the implementation on the back end. It handles that for you based on the definition you've defined. So really powerful, but very complex as well to do it correctly.
There's another question on there too. Have you ever had the conversation where people are like, but it's the cloud, so I don't need to do whatever, like VPC flows or EC2 logging because it's cloud?
Yeah. Yes is the answer. And sometimes it is actually true. If you have other mitigating controls, then it's not 100% necessary for
Yeah.
VPC flow specifically. If you have any type of other IDS or IPS deployed into those environments, or you are being very strict about how you're defining your security groups, that only certain services can interact with other services, um, that would be kind of you being able to enhance or not necessarily need that VPC flow information, so you can review all of that VPC.
I would add that there are
information.
certain things as well that that with cloud there is a better approach to accomplishing it. And when the best example I can think of for this is port scanning. So in a traditional, like if you have a data center, if you were doing vulnerability scanning, you, in order to find out which hosts are there occupying an IP address and which ports are exposed, you would have to scan an entire range. Whereas with a cloud, you can gather all of that information by querying the cloud provider. So you don't actually have to do that level of the scanning. You can still do the scanning to look for vulnerabilities, but you don't have to do the scanning to look for things that are there because you can query for those things.
Yeah, absolutely. And that actually, whenever we do cloud assessments, we request, well, we do pen tests of cloud networks. Let me change that a little bit. Cloud assessments is a little bit different. But we do pen tests of a cloud network. We actually ask if they feel comfortable enough to give us kind of permission to actually see and describe those resources, so that way we aren't beating our heads against a wall. If we don't have to, we can enumerate that information and then identify, okay, is this actually correct? Are we expected to be able to communicate on this port? Yes. Okay, that makes sense. No. And we are able to communicate to it? That's weird. What's going on there? And so it gives us kind of an augmented pen testing, so that way we can be more effective for your environment. So yeah, there is a better kind of cloud native way for certain things, but then there are other things like having a SIM, so that way you're logging all of your information. That still needs to happen. So yeah, awesome question though. Were there any other questions?
I think that's the last one for now.
Cool. All right, so next slide. All right, so this is the vendor-specific implementation for identity and access management. And ironically for this, it's kind of all called identity and access management. So the one caveat there is being Azure Active Directory for Microsoft Azure. So AWS, there are policies that you can define. Those policies then get assigned to roles, and those roles can either be applied to services or to humans. And so that kind of covers those like kind of foundational principles for identity and access management in AWS. And then the resource policies I briefly kind of covered, so that way you can define a resource or policy on a resource like an S3 bucket, so that way other resources can communicate to it. Azure has the Azure Active Directory. That's for people and access management for your cloud and hybrid environments. And then the AAD is the AAD external identities is for being able to interact with other external identities. And then the domain services is more of the individual resources being able to join, say for like your virtual machines, being able to join them to your domain without deploying a domain controller inside of Azure. So that's kind of the three different identity and access management perspectives for Azure. And then GCP, there's the roles and service accounts. Roles is for humans, and then service accounts is for services. So those are the vendor specific. Next, we are talking about account segmentation. So this is kind of a different concept from what you would typically think about as on-prem. You can kind of think about it if you're a bit more experienced with Active Directory. Think of it like creating groups and then putting people in groups. And you want to aggregate those groups based on a specific permission level or permission need. So you can have sub-accounts. So you can have one higher level like root or top level account, and then you can have sub-accounts, and each cloud has their own acronym for those accounts. There's tenants in Azure and organizations in GCP. But you have those sub-accounts that then get access to only the resources that they need. That way you can allow them to have more like freedom, but not have them impact and affect your actual top level account or your root account. Your root account is kind of like the king of the keys of the kingdom. That's something you don't really want people to have access to, and allows you to be like kind of the puppet master behind all of your other organizations and accounts. And then that example of on-prem, you can kind of think of like Active Directory and being able to assign people to those organizations. So that's kind of a description of what account segmentation is. And now going into vendor specific. Don't worry if you can't read those pictures. We're about to blow them up so that way you can see easier. But I just wanted to cover the names of what those are for the individual clouds first. So account segmentation and the service that you would use for AWS would be organizations. AWS organizations allows you to do that kind of tiering of accounts. And then in Azure, it's called management groups. And then in GCP, it's called organization policy service. And these pictures were actually taken from the individual cloud websites or cloud vendors' websites. So that way they kind of describe what the best practice is for them. And I have links for where I got them at in the notes, the speaker notes, so you'll be able to have access to those. So organizations. With AWS, you create a root level organization that allows you to create those policies and allow cross-account services and policies for those services. So say you have a database account over here and an application account over here. Typically, you wouldn't get that granular. You'd want to try and group them together, but just hypothesize for a second. And that way you can allow them to interact with each other if necessary. You have these policies that apply to the individual organizational units, and then you can have members inside of those accounts. So that's kind of from an AWS perspective, how they talk about being able to segment your accounts. Next, we have Azure. This is, you create a management group and subscription organization. From there, you have the tenant root, and you then create management groups below that root tenant that you can then delegate your individual slicing up of how you need to have it. Once you have those management groups, you can then provide subscriptions for those individual groups. And subscriptions are essentially like the services that you want to deploy and what services are allowed for each of those accounts. So that's kind of like the tiering of being able to do account segmentation in Azure. And then next is organizational policy service. This is a bit different than the other vendors. You have that like root level organization that creates the policy administrator creates the org policy, and then you can apply that to a blueprint for other GCP services or you can do it on a resource hierarchy node, which then gets inherited by those following subsequent descendant nodes. So that's kind of a brief overview of the different cloud vendors' description of account segmentation. All right, so next is logging and monitoring. So for logging and monitoring, you want to make sure that you're getting all of your cloud metrics. So that would be if someone creates an account in your cloud, you want to make sure you keep track of that. You also then have individual like web services that you need to make sure that you're capturing the logs for. And if you are being more cloud native, those can be in your cloud metrics. But if you're not more cloud native, you need to make sure you're grabbing those from the individual services that the operating system is deployed on. Next is the actual system logs. So that would be like your more traditional EC2 or servers, virtual servers that get deployed into your cloud. Those are more of the system logs, which unfortunately Azure has a different definition for a system log. But system as in like operating system logs. And then you want to make sure you're aggregating all of your authentication logs as well. So that way you can track if someone does hop between your different sub accounts, you want to make sure that you're being able to track them as they take action through different accounts, and where and when and who is accessing what. And then you need to propagate all 4 of those to your sub accounts. So I laugh because it's unfortunate from the perspective of like how complicated it can be. But fortunately, the cloud vendors, or most of the cloud vendors, do actually provide kind of that like organizational or sub account logging in a very specific way. They typically tell you how you can do that sub account logging for those individual needs. So it's unfortunate because there's a lot there, but to ensure that you get the most accurate information, it's needed. So, all right. So next, the actual vendor-specific implementations. 1 second. So, logging and monitoring. In AWS, there is CloudTrail. I'm just going to go over the individual services first, and then I'll get into the information on the right-hand side. So we've got CloudTrail for AWS. We have Monitor Activity Log for Azure, and then we have Cloud Audit Logs for GCP. With AWS, CloudTrail gets automatically activated when you create your account. That doesn't mean that it's configured, but it is enabled. So that way you can start configuring the logging for it. Then there are different types of records that you can do. There's event history, which that's about 90 days of management logs in the individual regions themselves. There are CloudTrail lakes, and those are, you can think more of like data lakes for all of your cloud metrics. That way you can do more advanced analysis of the user and API activity. And clarification, I just realized API, I hadn't described before, is typically the way you can interact with individual cloud vendors over the internet. So you can use their web UI, or you can programmatically use it via API, which other tools like Terraform and Kubernetes and other things hook into. And those are just REST web requests. I don't think I could say that 5 times fast. So that API activity and your user activity in the web UI is going to be stored in that CloudTrail lake. And then Trails is typically the most common way that you aggregate log information, and you can configure the individual resources to point their cloud logs to those trails. And that's how you can kind of aggregate all of your information. And that's actually how you would also aggregate the information if you do want to send it to something like a SIM. That way you can have them all together. For Azure, there's platform logs, and platform logs, although it sounds like operating system logs, it's not that. It is essentially detailed diagnostics and auditing information for Azure resources and the platform they depend on. So it's not necessarily, so yeah, okay. I'll just leave it at that. And I have a cited source for that on Azure's website to get more information on it if you want. From there, using the activity log, monitor activity log service, you can send it to 3 different places. So you can send it to the Azure monitor logs, which is for short term or for complex querying and analysis. There's the Azure Event Hub. That would be if you wanted to forward those events or those logs to external services, to like a SIM or something like that. And then there's the Azure Storage, which is you being able to store it in a cheaper long-term place for archival purposes. And then lastly, GCP. Not all services provide audit logs yet. They have a link, which I included in the speaker notes, for where you can check to make sure if the application platform or if the resource in GCP supports it and what level they support it at. So there's admin activity, which is like if you modify the configuration or the metadata of a resource. So like if you create a virtual machine, or if you change identity and access or IAM permissions, then that would be kind of classified as admin activity. Then there's data activity, where you can like read from a storage or a object storage bucket. And then the third one is system events. This is like Google Cloud taking action on your account for you. So for example, with GCP's BigQuery, you can set an expiration time on a table so that way it automatically gets deleted. And so say you wanted it to be deleted after like 5 days or something like that. That allows GCP to say, hey, I want activity or an action taken on this specific item. And that would be a system event. It's kind of nuanced and odd, but it's because it's coming from GCP itself compared to an individual person. And then policy denied is if an actual service or user tries to perform an action and they're prevented from performing that action by a security policy. Okay. So next is native security tools. These tools are for actually allowing you to have a more easier onboarding for this security. So kind of what I was talking about before, where it's difficult to grab individual services and then all of your sub accounts. If you were to try and do that all by hand, it's not very easy. And then also being able to analyze all that information is also not very easy. So the individual vendors have specific tools for doing it. And then there are other SIM like tools where you can ingest that information and they automatically create alerts. So on to the vendor specific. Again, don't worry if you can see the pictures, they'll be enhanced in a second, or enlarged, not enhanced. Guard Duty and Security Hub, then that's AWS, and then Microsoft Sentinel, that's for Azure, and then Security Command Center is for GCP. And then we'll go into the actual. So for Guard Duty, you can enable it in the UI, and then it can automatically or intelligently detect threats. That allows you to have non-standard activity be automatically detected. So we actually were caught by one of these, and whenever you actually deploy a malicious or a high privileged container in a Kubernetes cluster in AWS, this actually throws an alert for that. So whenever, because that's not something that's normal if a user just deploys it. Alternatively, it can notify you for if a service account on a server gets compromised, and then those credentials get used outside of that server's context. So I had owned a server in a client Kubernetes cluster, and then I grabbed the credentials and ran them locally on my machine, and it threw an alert for that as well. So those are some really good examples of something that you might not necessarily have the time or expertise to actually notice and identify, but AWS has built in this type of notification into their platform. And then Microsoft Azure's Sentinel. This is actually starting to get kind of interesting because there's the security copilot that kind of helps augment this Sentinel interaction as well. It allows you to be able to kind of have more of a more native understanding for the information that you're given. And then lastly is the security command center. And we actually were caught by this for another client. Whenever we created like a telnet reverse shell, it threw an alert saying, hey, this appears to be a reverse shell on your server. You might want to investigate it. And then you can also take action inside the web UI as well. The other vendors allow you to do that as well, but that's just kind of an example of our personal experience with it. And then best practices validation. So one thing that from a more vendor neutral perspective, you need to be cognizant of is cloud API rate limits. So whenever you have external tools to the platform, those are all going to request API or do API requests. And so those can be rate limited. But so that's just kind of a caveat to think about whenever you're doing this best practices validation. One of the things that kind of helps enhance you being able to have best practices is doing what I was talking about before, is using infrastructure as code. And then you can use static analysis tools to analyze your code to make sure that, hey, you probably don't want everyone on the internet to access your S3 bucket. Are you sure? And it would send like a warning or notification while it's analyzing your code. So that kind of helps augment your development of your infrastructure. So that way it can be a more code first and repeatable approach, but then also have tools that go back and validate, hey, is this a best practice for AWS or for Azure in general? So those are kind of some examples of how you can have that best practices validation. You can also use something, or you can use CI/CD or continuous integration and continuous deployment tools to generate reports for you. So for example, Scout Suite is a tool that allows you to analyze your cloud and identify if you're following not best practices. So if you're not following best practices is a better way to describe that. So you can take that and just do periodic reports of your cloud environment, allowing you to actually determine, hey, did someone misconfigure something because they didn't know that this was a best practice? Being able to have that kind of continuous monitoring allows you to get more of an objective perspective of your cloud environment. You can use AI and ML tools, but you need to be careful about that because whenever you do end up using them, most of the time they're okay, but you need to be careful of what's called hallucination. So where it's creating something that's technically inaccurate, but it believes that it's accurate based on the information it was given. An example of hallucination was that for a while there were people that were trying to determine package hallucinations for different programming languages. And so if it recommended a library that wasn't existing, someone malicious would go and create that package. So whenever they went to follow the instructions of like ChatGPT, it would then recommend that malicious package, not knowing that it was actually malicious because that's what it thought was accurate. So like the old adage is trust but verify. You can use specifically for that instance, there's a libraries.io page that is really good for being able to help rate or assess packages. So if you end up using AI or ML tools, just be cognizant and make sure that you have other ways of validating that. And then lastly, you can kind of use standards to do that. A really good example is CIS benchmarks that give you practical steps on how you can implement best practices in your cloud environment. And then the actual cloud vendors themselves have essentially best practice validations integrated into the actual cloud providers. So AWS, it's the well-architected framework. And it's kind of funny. I think, I'm not sure which one came first, but they all said well-architected, and I knew of AWS as well-architected first before everyone else. So it's kind of interesting. So they're all pretty much called well-architected, but these are the links to where you can follow those guides as to what those individual cloud vendors say are the best practices for their cloud environment. So kind of wrapping up here, it's really difficult, but it's very worth it if it's embraced from the beginning. So don't feel like you're the only person out there that's suffering through it. I promise you, we all are. Just try and do your best and ask for help if you can't, if you don't know. Training and experimentation, allowing your staff to be trained and to experiment in like almost lab type accounts allows them to do any type of screw up or mess up in an environment where it's not production critical.
Yeah, that's actually, I think, I don't think you can understate that, or I don't think you can overstate that. Rather, the ability to stand up an account, do anything you want to it, and a lot of the cloud provided services have free tiers for specifically for trying things out. So it doesn't usually typically cost you anything, or if it does, it's usually just a little bit to experiment with these sorts of features and try them out and see what works. So
yeah,
and then you can throw it away. Almost no risk at all. So.
Exactly. Allowing that experimentation is just like critical for you to actually be able to test things and make sure it is implemented correctly. Yeah. And then being able to blow them away because it is like a more dynamic environment. It's on demand, like Jason was saying. It's really nice because then you don't have that type of risk of, hey, this was created, but should it still be running? You can just destroy the whole account if you want to. And then some resources. These are the links that I use for trying to find the service comparisons. And those are on the different cloud providers' websites. And then ChatGPT, actually, I was able to give it, hey, this service looks for, or what does this service mean in AWS, or what is this service in GCP or Azure? And it did hallucinate a little bit, just like I was saying. So I didn't use it for any of the content on the slides, but I did find for service comparison, it actually was pretty good.
I also want to add around the training, both AWS and Azure, I have been working through some of their training that they host about this stuff, and it's very comprehensive and gives you a good deep dive into what each platform needs.
And
so
am I right?
A lot of support.
All or most of that training is available. Like, isn't a lot of that for free? Or
yeah, a lot of it's for free, or it's accessible with some accounts.
So I think
Yeah.
that's a big deal too. A lot of people might assume that there's this barrier to entry where you have to put a bunch of money down for a class or something, but yeah, I don't think
It's to get the
case.
certifications typically that cost money from them. It's not the
Just
classes
cert.
themselves. Yeah.
Yeah.
Yeah, so definitely make sure that you look at those, and then there are a lot of other resources online, but I would look at the cloud-specific vendor first to see if they have, because they're going to have the best recommendation for you. So, and then lastly, kind of a shameless plug, we have advisory services if you do need help. So that way we can kind of just chat in Slack, so that way you can try and evaluate what's best for you and your organization and kind of have that helping hand.
Yeah.
Cool.
Yeah, I mean, if you just have a quick question or something, you can just ask us in the either Professional Evil Slack or send us an email. But if you actually want help working through something, then that would be we have advisory services specifically to help with that type of thing. So it's good.
Yeah.
Good stuff. Does anybody have any questions for Alex or Doug or both? Things to throw? Okay. In that case, I think what we'll do is we'll stop right here. I know we there was one question I was going back and forth in the chat with one of our attendees with, and I think we kind of came to the conclusion that we know that there's a way to do this thing with SSM logging, but we weren't sure exactly what the details are, and it seemed like it was too detailed for this talk. So we'll just leave that there and maybe circle back another time. So thanks for joining. Next Friday, I believe it is, we are doing a talk on about backups and how they relate to ransomware. So that might be relevant to people. That will be with Eric and Bill, I think. And then on our next session after that is scheduled for October 11th. Right now, I think I'm not sure if that's in stone, but it sounds like a very exciting talk, so I want to mention it. Exploring the Flipper Zero. So Travis is going to be talking about using Flipper Zero as a hardware hacking tool. So that should be really cool too. And then we're doing a Halloween special one too. So definitely tell people about that. So that'll be right now. It's tentatively scheduled for the 18th. I don't know if that's in stone, but yeah. So should be good.
We have those listed on securideas.com/webinars if you're interested too. So
yeah, definitely check that out. Also, upcoming conferences. Some of us will be at InfoSec World near the end of the month. I can't remember the exact dates of that one. It's like the last week in September. It's all a blur right now. See, what's happened is we've kind of gotten into the fourth quarter a little bit early, and we've gotten very, very busy. So we have InfoSec World in Orlando, and then we have GurCon up in Grand Rapids right after that. So several of us will be at both of those conferences, and hopefully we'll see some of you there. So thanks a lot, Doug. Thanks, Alex. Much appreciated.
Yep.
Absolutely. Thank you.